Okay, being a few minutes late, I had a failed stream connection, and that's what impeded me from being, I was on time, except I had to restart. Okay. Okay, here we go. Let's go to control room. View. Okay, we got Adam in the house. Okay. Okay, I had Adam commented, and it says 5 watching now, so I guess we're on go. Thank you for being here today. Again, I'm going to make a recording of this available for later. And, okay. All right, Kaylee, very good. I want to show you today, I have, I'm going to eventually have a webcam so you can see me while I'm working this, but until then, I'm going to show you a picture of me. There I am at my workstation, so that's what I'm looking like today, wearing my basketball playoffs long sleeve t-shirt. Okay, so I guess we're just going to go through the even numbered ones here, and just chime in if you have any questions and want to particularly look at something. Again, what we're going to do for number 2, like we did for number 1, is we solve one side of the equation for 0, and to do that, we subtract 3 from both sides. So it's going to be y is equal to x over 2x minus 10 minus 3. And we're just going to fill that in. I'm going to get a skinnier pen here. And so if we plug in 0, we're going to get 0 for x, which makes this whole first thing 0. So we're going to get y value of negative 3. So our coordinate's going to be 0, comma, negative 3. Next, if we plug in 3, I'm just going to work this out, or y equals 3 over 2 times 3 minus 10 minus 3, which is going to be 2 times 3 is 6. 6 minus 10 is 4, so we're going to get 3/4 minus 3, which is going to be equal to negative 2.75. So we get 0, comma, negative 2.75. And if we plug in 4, two times 4 minus 10 minus 3, I'm just going to work to the right. So we get 4 over 8 minus 10, which is going to be negative 2 minus 3. So 4 minus negative 2, that's negative 2 minus 3 is going to be negative 5. So we put, that somehow doesn't look right, does it? Because we put 8. Let's see what we should have here. Yeah, I got that second one wrong. This should be minus 3.75. I can't even work this right. Negative 3.75. Okay, here we go. Yeah, so this 4 is negative 5. So we got 0, comma, negative 5. And then if we put in 5.5 over 2 times 5.5, or 2 times, yeah, 2 times 5.5 minus 10 minus 3. So 2 minus 5.5, that's going to be 11. 11 minus 10 is 1. 5.5. So we're going to get 5.5, 2.5. So 2.5. So we get, man, I'm just messing this up all the way around. Got to get my x coordinates right. Okay, these x coordinates are going to be, this is 0 for sure. This is going to be 3, 4, 5.5, comma 2.5. Yeah, my pen's a little glitchy. What happens is my streaming service uses resources. So for 7 we get 7 over 2 times 7 minus 10, and then minus 3, which is going to be equal to 2 times 7 minus 10. That's going to be 14 minus 10, so that's going to be 7/4. Right, because we got 14 minus 4, so 7/4 minus 3. 7/4, that would be 2.25 minus 3, so that's be negative 0.75. So we get 7, negative 0.75. And the last one we do is 10. So y is equal to 10 over 2 times 10, 2 times 10 minus 10 minus 3. So we'll have 20 minus 10. That's going to be 10. So we'll get, that's going to be 10 over 10 is 1 minus, we get negative 2. So now we get negative 2 here. We get 0.10 comma negative 2. And so we go through here and put in just our points here, 0, -3. We'll put in 3, -3.75. There's 3, -3.75. We put in 4, we get -5. Okay, and then we put in 5.5, we get 2.5. So 5.5, 2.5. We put in 7, we get -0.75. And we put in 10, we get -2. So what we're looking like is this. So we can see that we have a vertical asymptote right here and a horizontal asymptote right here. And that's as far as I want to take that one. We're going to take our denominators and just factor them and just see what we can put together to get a common denominator out of these. So 5x minus 30 can be factored out. What's our common factor? 5. 5 times x minus 6. Okay, so that's one of our denominators. And this 7x minus 42 is going to be equal to 7 times x minus 6. So x minus 6 is definitely common between those two. And I think we have to look at, so we have a 5 and a 7, and they are not factors of each other. So our least common denominator is going to be equal to our 7 times our 5 times this x minus 6. So that's going to be equal to 35 times quantity x minus 6. And so what this effectively means is that if we have this rational equation, we can multiply through both expressions by this least common denominator. We can clear the denominator, and that's the least we can make for it. So that's really the simplicity of that one. So we'll put LCD is equal to 35 times quantity x minus 6. Okay, there we go. Okay, next. Here we have, again, we're still finding least common denominator. So we have x squared minus 3x minus 28. And what is that going to be equal to? Well, we're going to try to factor that. What are our factors of this? Well, we have x and x. And then two numbers that multiply together equal -28, but added together equal -3. What are your factors of 28? I'm thinking of 7 and 4. Right? So 7 and 4. And we have minus 3x. So that means our 7 is going to have to be our bigger number, or negative. So x minus 7, x plus 4. Okay, and next we have this x squared minus 2x minus 24, and factoring that, we have x and x, and we have a negative 24, so we're going to have a plus and minus. So what are the two numbers that multiply together equal negative 24 but add together equal negative 2? Well, 6 and 4, right? Because they are 2 apart. So 6 and 4. And again, our negative is our bigger one, so we're going to have minus 6 and plus 4. And now for our least common denominator, we look at all these factors. We can see that between these two denominators, we have this x plus 4 in common. So our least common denominator is going to be this x plus 4. But also we're going to need to have this x minus 7 and this x minus 6. And so really that is our least common denominator. Okay, next we're going to look at number 8. Again, we're looking for least common denominator between these two denominators. Okay, so we're going to have this 5x squared minus 40x minus 60, and that's going to be equal to put our common factor 5 times x squared minus 8x and 60 divided by 5 is 12. So that's going to be equal to 5 times, let's factor this x squared minus 8x minus 12, so we have x and x, we know that, and what two numbers, okay, we got are that far apart? Well, this is one where the book, bless their heart, made a mistake, because this one here together equal 12, but when added equal negative 8, well, it's going to be 6 and 2 squared plus 56x plus 84. If we take our common factor here of negative 7, we have x squared. What times negative 7 equals 56? Well, it'll be negative 8. And what times negative 7 equals negative 84? It's going to be plus or minus 12. Should be plus 84. Yeah, it's going to be plus. Should end up being the same. It's 12. So we get negative 7 times x minus 6. There's quantity x minus 2. So our LCD is going to be equal to this negative 7 times 5, which would be negative 35. And then these are the same in each case. We have x minus 6. It's quantity x minus 2. So really that's it. Okay. The equations. And we're going to solve these algebraically. Well, the first thing we're going to do is find our least common denominator. So our least common denominator is going to be equal to this 7 times this denominator of x plus 1. And the principle we're going to be using here is clear the denominator. So we're going to, if we multiply by the right least common denominator, we're going to clear out all the denominators and have a linear or quadratic equation that'll be pretty easy to solve. As far as what x cannot be, well, we know that x plus 1 cannot equal 0, so x cannot equal negative 1. So that's going to be an excluded value. So we're going to rewrite this fraction multiplying by our least common denominator. So we have 3 over x plus 1, and we're going to multiply this by 7 times x plus 1 plus 2 sevenths times 7 times x plus 1, and that's going to be equal to 2 times 7 times x plus 1. And then we can just cancel things. That cancels that. This 7 cancels this 7. And so we just write what we have left. We have 21 is equal to 2 times x plus 2 times 1. So 21 plus 2x plus 2 times 1, which is 2, is going to be equal to 14x. And where do we get 14? 2 times 7 plus 14. So what do we have left here? Well, we have on the left side we have 23 plus 2x, and the right side we have 14x plus 14. So we can do a double switch. And we can subtract 14 from both sides. and subtract 2x from both sides. And we do that, we have cancellations here and cancellations here, and what do we have left? We have 23 minus 14, which is 9. And then on the right side we have 14x minus 2x, which is 12x. And now we divide by 12. So we have x is equal to 9 over 12, which is 3/4. And the last thing we do is we take a look and see if that happens to be one of our excluded values. It is not. So this is our answer. X equals 3/4. Okay, next. We have 12. Let's see how far we want to go today. Okay, we're getting into the word problem. So we'll just do these last. I don't want to get into these word problems. I just want to go through 14 today. So let's go ahead, and the first thing we're going to do is find our least common denominator. And we're going to find this x squared minus 10x plus 21. And what does that factor out to? We have x and x. And we got negative 10x. Oh, okay, Abigail in the house. Very good, Abigail. Good to see you this fine morning. Yeah, Abigail, if you just joined in, you'll be able to watch the replay later. That'll be fine. Good to have you here. Okay, next, let's see, what two numbers, are there two numbers that multiply together equal 21 but add together equal 10? I'm thinking 3 and 7. And we know that we're going to have negative, negative. So really that's all we're going to need. So we already have our least common denominators here. So we're going to have our least common denominator, which we're going to multiply by through to clear out this whole denominator, is just going to be this x minus 3, and this also this x minus 7. And we know just from looking at this that what are our excluded values? X cannot equal 3, nor can x equal 7. Okay, so now we're just going to apply that to what we have here. So I'm going to just rewrite. It's going to be pretty long here, but we can do this. We'll put x squared minus 29 on top, and on the bottom we're going to put x squared minus 10x plus 21, and then we're going to multiply that through by x minus 3, x minus 7. So you see how that's going to clear out this whole denominator here, and then it's going to be equal to 6 over x minus 7 and we multiply that by our least common denominator of x minus 3, x minus 7. So you can really see here, can't you, how getting this least common denominator makes life easier for us. So we get this x minus 3 here. Down below and on top we put x minus 3, x minus 7. And how can you tell if you have a good least common denominator? You can tell by this, that everything will cancel out in the denominator. So this x minus 3, x minus 7 will cancel out this denominator. This x minus 7 down here is canceled out by this x minus 7 on top. And this x minus 3 on bottom is canceled out by this x minus 3 on top. So what we have is we have x squared minus 29 is equal to 6. I have to write a little bit slow because of the glitchiness of this thing. Plus 5 times x minus 7. And just distributing here, we have x squared minus 29 is equal to 6x, and 6 times negative 3 minus 18. And then we have plus 5x minus 35. And we'll just try to, so we can just combine like terms on the right. So let's just do that. We have 6x plus 5x, that's going to be 11x. And then we have negative 18 minus 35. Let's see, that's going to be, is that going to be minus 53? I think it is, right? And then we have x squared minus 29 on the left. And now I'm going to do a double switch here. I'm going to go ahead and subtract out 11x. And add 53 to both sides. So these will cancel out on the right. So we have 0, because that's what's on the right here, right? Equals x squared. And we have minus 11x. And then we have negative 29 plus 53. That's 24, isn't it? Because 3 minus 24, yeah, 24. Plus 24. Well, and factoring that out, that's going to be x minus, that's going to be 3 and 8, isn't it? X minus 3. X minus 8. Is that right? That should be right. So we have, just working the right, we have x is equal to 3, because if we solve, if we set x minus 3 equals 0, and x minus 8 equals 0, we have x equals 3, x equals 8. Now, this 3 is an excluded value, so we call this, when you solve and have an excluded value, this x equals 3, this is called an extraneous solution. Which is not a real solution. So that, but this x equals 8, that, my young friends, that is what we call a real solution. So real solution. Sometimes you'll solve these things, and I've seen it where both solutions are extraneous. So we have an extraneous solution and a real solution. Okay. So that's number 12. And then we have number 14. I want to really stop with 14 because then we're getting to word problems after that. So our common denominators, we got x minus 2. Let's work on this one right here. We have x squared minus 3x plus 2. And what are the factors of that? Well, we're going to have x minus 2 and x minus 1. Okay, and this 3x minus 3, that's going to be equal to 3 times x minus 1. And then we have this x minus 2. So already we know that just exclude values, x cannot equal 1, and also x cannot equal 2. Right? Because that would make dividing by 0. So our least common denominator is just kind of looking at all these together. Well, we have this number 3 we have to account for. So we have 3, and then we have x minus 2 and x minus 1. That's going to pick up all of our So if we multiply by this least common denominator, we're going to clear out everything in our denominators here and just have a problem we can solve. Yeah, Linus, we have Linus. Don't recognize the name. We're really happy to have you here, Linus. Yeah, you can't divide by 0. That's right. So that's a good observation, Linus. Appreciate you being here. Now next, let's just rewrite this. We'll put in, again, this is going to work out to the right here. So we got x squared minus 3x plus 2. And then up here in the top, we're going to put times 3 times x minus 2, x minus 1. And then we have minus 1 over x minus 2. And then we have on the top here, we have 3 times x minus 2, x minus 1. And that's going to be equal to x plus 6 over 3x. I'm going to rewrite this 3x as 3 times quantity x minus 1. And it's going to, I write it this way to just make it easier to visualize what were our cancellations. So on the top we have 3 times x minus 2, x minus 1. And so we just cancel stuff out. We have this x minus 2, x minus 1 will cancel out this x squared minus 3x plus 2. And here, this next one, we have this x minus 2 will cancel out this x minus 2. And we have this 3 cancel out this 3 here. And this x minus 1 cancel out this x minus 1. So we write what we have left. All we have left for this first one is 15. And then that's going to be minus, we have 1, or actually we have 3 times, I'm just going to multiply through, we have 3 times x and 3 minus 1 So we're going to have minus 3x, and then we have minus 3 times 1 is negative 3, and minus negative 3, that's going to be plus 3. And that's going to be equal to, on the right side, we have, all we have left is this x plus 6, x minus 2. So we have x squared, and then for this, multiplying these together, 6 times x is 6x, minus 2x, so we're going to have plus 4x. And then we're going to have 6 times negative 2, that's going to be negative 12. So what we have here on the left is negative 3x plus 18. Okay, that's going to be equal to x squared. I'm just rewriting this. X squared plus 4x minus 12. And so we're going to do double switch here. Make sure we're getting toward the end of this thing here. If you have any other questions, let me know. I'm planning to make a video sort of talking about where we're going this week. I hope everybody has a good Easter plan. Plus 5x minus 18. So we have 0 is equal to x squared plus 7x, and we have minus 30. So let's see if we can factor that out. I haven't done this in advance. What is this going to be? We're going to have x and x, and we're going to have a plus and minus. So 5 and 6 will be separated by 1. How about 3 and 10? Yeah, I think 3 and 10 is going to work, isn't it? So we put 3 and 10 here. And then we have 7. It's positive 7, so it's going to be x plus 10 and x minus 3. So let's see here. We're going to have x solving for 0 because we have x minus 3 is equal to 0, and also x plus 10 is equal to 0. So from this, we have x equals 3, x is equal to negative 10, and so we see that none of those are excluded values here, so these would be our correct answers. So we're just about done here. I want to do one last thing with this particular problem, is go to a calculator just to show you how these problems can be solved by graphing. And what I'm going to do is rewrite this number 14 and just show how it can be solved. So we're going to put, what we do is we solve one side for 0, so we put alpha y equals, enter, and we're going to put 5 over x squared minus 3x plus 2, and over here we're going to put minus (1) over x minus 2 and then what we're doing is we want to set the right side equal to 0, so we're going to subtract the other fraction, and so we have x plus 6 here in the numerator, and in the denominator we put 3x minus 3. What this is a technique solving by graphing. So we graph this, and what we look for is where the function touches or crosses the x-axis. So I'm going to just zoom in on this a little bit. Let's go to, I'm going to change the window to -12 here, and I'm going to change the scale, change the y min, y max. I'm going to go from y equals -1 to 1. And you see where we touch or cross the x-axis here at -10 and here at +3. If we go to table view, we can also see the second graph. There we go. We can see we have 3, 0 and we have -10, 0. So that's another way to work these out. Anyway, that's it for the day. I don't have anything else set up. Again, look for some kind of video later or tomorrow or sometime to really introduce what we're going to work on next week. Work on exponential functions next week, exponential growth functions, which is really a big deal with this coronavirus pandemic we're fighting, and everybody I see is doing your part for that, so I certainly thank you for that. So that's it. I'm going to go ahead and end this live stream. Again, thanks everybody for being here. Take care. Bye now.